Okay, so today we are extending tables. And before we go any further, we got some special vocab. Now we have arithmetic, okay? Arithmetic or arithmetic, however you want to say it, means you have an adding or subtracting pattern, okay? Geometric, okay, means you have multiplication or secret division as you go down the pattern of your table, okay? Make sure you write, up top here so that you have space to glue in your guy later. So first things first, we have an arithmetic starting at time 0, okay? So it is starting at time 0 because of that first x or that first n value, that is a 0. So that's why it's considered time 0, okay? And then here's my pattern as we go down. We got 9, 7, 5, 3, okay? Now, as we go down our table, I see that the pattern is subtracting by 2. So when you fill out the extended side of your table, you always bring that first f of n or that first y value, bring that straight over because there's just a 9 there. That's all that happened. But to get to that 7, we had to do 9 minus 2. We took that first number and subtracted 2. To get down to this 5, we took that 9 and we minused 2 twice, right? And then to get to this 3 here, we took that 9 and we minused 2 3 times, okay? So that's the pattern that's going on. And notice, you start with what you began with, and then you just, what the math you do, you just keep adding it on as you go down your table. So when we write the recursive, which we've already seen before, the recursive always starts is f of n equals f of n minus 1. We subtracted 2 as we went down our table, so that's why I have this underlined in blue. And then you have to give what you started with. We started with 0 and 9, so we have to write f of 0 equals 9. Okay, so that's how the recursive goes. The explicit equation kind of follows your extended pattern that's going on here, right? It's going to go f of n equals 9 minus 2, right? We started with that. We're subtracting by 2 as we go down. And then we're going to have just an n because we start at time 0. I'm going to repeat that. You have just a regular sized n because you start at time 0. And it's regular sized because we are adding or subtracting. That's going to be important. All right, so let's look at another one together and let's fill it out. Right. So here's our pattern this time. Notice we have 9, 7, 5, 3. We have that again. So we already know we're starting with 9, and then we do 9 minus 2, and then we do 9 minus 2 twice. So the recursive is always going to start as f of n equals f of n minus 1. Always, that's just how it is. That's formatting, right? But as we go down the table, we are subtracting by 2. So I'm going to put minus 2. That is the pattern. That is the common difference. Okay, so after that, though, we have to give what we started with. So what you started with is always going to be kind of written in this. I'm going to put the stuff in black that you always write. So we start with time 1 this time. So I'm going to put a 1 inside of the parentheses, right? An arithmetic with a positive time. We started with a positive 1, so that's a 1 in there. And then we also started with that 9 again. So the only difference between this time 0 and this positive time is right there. That's it. That's the only difference between the two. And then the explicit, right? The explicit is always going to start as f of n equals. And then we kind of write it out the same way. We started with that 9. We are subtracting by 2 as we go down the table. But we didn't start at time 0. We started at time 1. So what we're going to do is we're going to write parentheses n. And then to incorporate that 1 we started with, what we're going to do is we're going to do n minus 1. Okay, so whenever you start with a time that is not 0, you have to do the opposite, right? And the reason why we do this is because right here, how many minus 2's do we have? We have 0, okay? So what we have to do is we have to take our x value or our n value, and we have to subtract that away so that it would be correct, right? So that you would have 1 minus 1 to prove that it's 0. Because if you don't, if you do the mathiness that goes with it, it's not going to work out. Okay, so again, you always want to do the opposite of the start time if it's not 0. So if it's a positive 1, you want to write minus 1 inside of that parentheses. And again, they're regular sized because we have adding or subtracting for our variables. Okay, so the next one here. Okay, so the pattern is the same, right? But this time we start with a -3 as our time, right? We have a negative time. So our recursive equation starts out the same, f of n equals f of n minus 1. We are still subtracting by 2, but our starting point starts with f of -3 equals 9, okay? And the explicit equation, again, starts out the exact same as the last time, right? 9 minus 2, still got that 9 minus 2 because that's what we started with, what we're doing. But to show this -3 is what we're starting with as our time, we have to do parentheses and plus 3. You want to do the opposite of that start time. So that's why we get that plus 3 from. And again, put parentheses around it so you don't make any silly mistakes. Okay, geometric times 0. So geometric means we are multiplying or got secret division. So in this one, we have 3, 15, 75, 375. Now notice these numbers are getting big really fast. So that's a really good indicator that you are probably using multiplication. Start time is 0. We started with 3, but we are multiplying by 5 as we go down the table. Okay, so the recursive, exactly the same as an arithmetic recursive, right? Exactly the same. Starts with f of n equals f of n minus 1, but we are multiplying by 5 as we go down the table. We started with 0 and 3, so I write the starting point, f of 0 equals 3. The explicit equation, very similar, except, so we have the start. We started with 3, so I start with 3. We're multiplying by 5, so I'm multiplying by 5. And this time, I'm going to have an exponent n, okay? Whenever you are multiplying or having secret division, you want to have an exponent for your variable. And I'm going to put just an n because it's just a times 0 that we started with. If we have a geometric positive time, okay, so this one starts with 3. So we have 3 and 3. There's a lot of 3's in this one, so be ready. Same pattern, 3 times 5, 3 times 5 twice, 3 times 5 3 times, recursive, f of x equals f of x minus 1 times 5, and I'm only using x's because my table had x's. That's the only reason. There's nothing special about it. Start time is f of 3 equals 3 because I started with the 3 here instead of the 0 like earlier. Same thing with the explicit. The pattern of how you write it out is going to be the same. F of x equals 3 times 5, and then exponent x, and we do minus 3 because we want to do the opposite of our start time. You always want to do the opposite of your start time when you are filling out your explicit equation. We will talk more about that in class about why we do that opposite start time. Okay, and then lastly is a negative time. So again, that pattern is going to be the same down the extended table because we are multiplying by 5. But this time we start with a -1. So our recursive is going to be written as f of n equals f of n minus 1 times 5. Then we have f of -1 equals 3 as our start point. For the explicit equation, again, we'll start out the same, 3 times 5. We start with 3, we are multiplying by 5 as we go down. Exponent's going to be an n plus 1 because you always want to do the opposite of your start time. All right, that's the end of this video, you guys. If you have questions, and I'm sure you will, we will definitely answer them in class for you. Have a great day.